Alright, so these problems have zero context, meaning there's no backdrop about heights or elevations, and they also look very similar to the problems here. So here you have a variable on each side, which we'll do in a moment, but here you have radical equations just with an expression. So these are a little bit less challenging on this page than these ones. Okay, rewriting the first problem. Square root of x plus 1 plus 7 equals 10. Now, since there's no other variable business going on anywhere else beyond the radical, this would be like the previous problems, where if we just had the square root of h over 4 or something, equal to some other side with no variables, we could just square it after doing some basic algebra. And it doesn't really matter that it's not just x, it's x plus 1, because once we square that, that will go away. So let's see how this works out. Okay, just like when you used to solve something like y plus 7 equals 10, all you would do is subtract 7 to get closer to getting the variable by itself. Square root of x plus 1 is equal to 3. If I get rid of that, then I'll have the x plus 1 equals 9. Subtract 1 from both sides, and x will be 8. Always a good idea to plug this back into the original problem. 8 plus 1 is 9. The square root of 9 is 3. 3 plus 7 is 10. And 10 does equal 10. Move on to the second one. If that felt okay, you can OYO this one and still listen to me talk through it. Alright, I see something. I just need to get rid of it. Add 2 to both sides, leaving you with square root of x minus 3 equals 6. To get rid of the radical, we're going to square both sides, and I'll have x minus 3 is 36. Add 3 to both sides, and I'll get x is 39. Let's check this out. 39 minus 3 is 36. The square root of 36 is 6. And 6 minus 2 is 4. And that's everything that's going on in my head to make sure that the left and right sides are equivalent. Moving on to the third problem. This one is definitely going to be an OEO problem, so I'm going to show the answer in 5 seconds. 4, 3, 2, 1. Okay, I got 99, so the only thing I'll walk through, because you can check each step along the way and make sure it looks okay if you got something different than me. 99 and 1 gives me 100. Square root of 100 is 10, plus 4 is 14. So that is how you would do these problems. And then we'll move on to these more challenging guys now. Okay, so we got square root of x plus 2, and that's equal to x minus 4. So get that rewritten. And squaring this is the only way I'm going to get rid of that radical, which means that in this original problem we're going to have to square the other side as well. And by squaring this other side, it's not like we're creating a nightmare. It is going to get a little bit more complicated though. Squaring a radical makes it go away, and I have what's on the inside. And then I'm going to FOIL writing x squared minus 8x plus 16. Now I want to look at this and realizing that there's a quadratic. That means that the only way I can solve for these is if 0 is isolated to one side. So I'll take x, and really if you want you can take away 2 as well. So I'm going to subtract x, subtract 2 from both sides, and I hope you're okay with me moving this to the left side so that I can rewrite x squared minus 9x plus 14 equals 0. And then hopefully these factor. So we're looking for the factors of 14 that add up to 9, and the way that this will work out is that x minus 2 times x minus 7 will give you 0. Whoops, made a mistake there. And you know that from the whole zero product deal, this means it's either 2 or 7. Now before I box this, I'm going to go ahead and plug these in and see if they work out. So let's look at this. 2 plus 2 is 4, and the square root of 4 gives me 2. However, on the right side, 2 minus 4 gives me a negative 2, so I'm going to have an erroneous answer here that won't work out. So I'm going to get rid of that guy, and I will just write x is equal to 7. I'm going to box this because I'm assuming that will work. Let's check it out, though. Over here, 7 and 2 give me 9, and the square root of 9 gives me 3. And then on the right side, 7 minus 4 gives me 3. So what's going to happen is you're going to end up, due to the whole radical deal and not being able to have a radical with a negative in it, there's going to be a need to check all these. Let's move on to problem 2. The square root of x plus 5 equals x plus 3. And this is set up, in structure the exact same way, where I'm going to have to square both sides, leaving me with x plus 5 on the left equals x squared plus 6x plus 9. Hopefully that made that plus sign clearer and not worse. Same as before, getting rid of x, getting rid of 5. Either do this in the same or separate steps. And I'm going to shuffle this over to the left. X squared plus 5x plus 4 equals 0. Looking for the factors of 4 that add up to 5, and that would be 4 and 1. So I'm going to write x plus 4 times x plus 1 is 0. I'm going to summarize this as being either negative 1 or negative 4. And then when I look at this, I'm going to plug these back in. So negative 1 plus 5 is positive 4. The square root of 4 gives me 2. And then negative 1 plus 3 gives me 2. So that left value, negative 1, works. Plugging in negative 4. Negative 4 plus 5 gives me positive 1. And the square root of positive 1 is 1. But then on the right side, when I'd add negative 4 and 3, I'd get negative 1. So in this one, only negative 1 works out. So x is equal to negative 1. Problem 3, on your own. The only thing that makes it different is that the radical's on the right side. So do this on your own, and I'll put the answer up in about 5, 4, 3, 2, 1. So I got x is equal to 5 because 2 didn't work out. Let me make a couple of small comments. Make sure that this exponent, whenever you're writing this, is clearly attached to the side of that radical and not just attached on the inside to the 1. Also, be aware that this is going on by itself. If we would have had something strange over here, then we would have had to have moved that over before squaring the whole side. So I think those are a couple comments about arranging your radicals and keeping out an eye for different problems. This step is really not totally necessary. By this point, if you're okay kind of loading up your working memory and seeing this move over to there. What else can I say about this? I think that's really about it. So of course, I mean, it has potential that these could eventually force you to use the quadratic formula or complete the square depending on the problem. So here are a ton of problems to go with this, and see how they go. So this one was only 2 videos, radical equations, and definitely a lot of different types of problems that you're able to solve now.